Hi everyone, in this video we will discuss the problem construct binary tree from in-order traversal and pre-order traversal. So let us read the problem statement and see what we can do here. So in this problem you are given the in-order and the post-order traversal of the binary tree. Okay, now what is in-order traversal first of all? So if you will see in-order traversal, so in-order traversal is basically where we first of all write left and then after that we write what? We write the root and then the right. So basically in-order traversal is first of all you have the left subtree, then the root node and then the right subtree. Okay, then what is post order? So post order traversal is basically when we have the left subtree, then the right subtree and then the root node. Okay, so you can observe one thing guys, that in post order the root is always at the last, and whenever you are constructing a tree, so which is the most important part? The most important part of a tree is the root node. So how you can access the root node? So if you have post order traversal, so the last nodes will indicate the root. Okay, and especially the last node of the given pre-order here will indicate the root node of the total tree, and then the next second last node will indicate the root of the other segment. Okay, and you can see here that whichever root we will have, right? So if you see that in the in-order array, so with respect to that root, with respect to the position of that root, all the nodes that are on the left, they will be in the left subtree, and all the nodes that will be on the right, they will lie in the right subtree of the tree. Okay, so let's quickly write this sample test case so that we can understand it better. So let's say we have been given the in-order and the pre-order array, and in this what we have is, let's say we have been given the in-order and the post-order array. Sorry. So if we have the in-order array and we have got 4, 8, 2, 5. Okay, let's say we have got the nodes as what? 4, then 8, then 2, and then 5. So we have got 4, 8, 2, 5. Then after that 1, 6, 3, 7. Okay. Then after that we have got what? 1, then 6, and then 3 and 7. Okay. So these are the nodes that we have got. Then after that in the post order what we have got? We have got 8, 4, 5, 2. Okay. So we have got what? 8, then 4, then 5, and then what? 2, and then 8, 4, 5, 2. After this we have got 6, 7, 3, 1. Okay, so after this we have got what? 6, then 7, then 3, and then 1. So these are the nodes that we have got here, right? Now after this what will happen is, like as I said, if you will see the in order, so in order is what? In order is basically, you can say, left subtree, then the root, and then the right. And post order is what? Post order is left, then the root, sorry, left, then the right, and then the root. So left, then right subtree, and then the root. So if you will see, if we keep one pointer here, and in this pointer, if suppose that initially my pointer is standing at the last element, so what does it indicate? This indicates a root node, because the last pointer is what? It is indicating the root node now. So this will indicate the root node. So basically this uh, pointer of the post order is indicating to the last element of the post order array, and the element is basically 1. This indicates that the root of the original tree is basically 1. So you can say that the root of the original tree is basically 1. Now if you look at the position of this element in the in order array, so in the in order array, if you will do the indexing here, so let's do some indexing so that we can be more clear. So let's say this is index 0, 1, 2, 3, 4, 5, 6, 7. So you can clearly observe guys that what happens is that all the people that are there, okay, so you can see that the element 1 is present where in the in order array. So it is present at the index 4. The element 1 in the in order array, it is present at the index 4. So all the people that are on the left, because right, because you can see that 1 is the root of the current tree. Okay, so with respect to it, whatever is on the left of 1 in the in order array, it will lie in the left subtree. So basically you can say that the nodes like 4, 8, 2 and 5, they will lie on the left subtree of 1. If you want to see the diagram, you can see this, right? You can see that the nodes, that is 4, 8, 2 and 5, they will lie on the left subtree. So you can see that the nodes that are lying on the left are 4, then 8 and 2 and 5. Okay, and all the nodes that are on the right of the node 1 in the in order array, they will lie in the right subtree. So let's say if this was the mid index where 1 is at, then from mid plus 1 till the end, till the high pointer, all the nodes will lie on the right subtree. And you can say that from lowest point till the mid minus 1, all the nodes will lie in the left subtree. Okay, so you can clearly see here that once this happens, so we can call on the left and the right. Okay, so suppose that if we call on the left, so now we are calling for 4, 8, 2 and 5. Okay, so this is the segment we'll be at. Now when you're calling for this particular segment, so you can clearly observe that the next node is what? Then the next node is basically 3. Okay, So we'll iterate in the array. And now since we have been given the post order traversal, post order is what? Root, then right, and then left. So since we have the post order, so we have the root, then the right subtree, then the left subtree. So now we have to consider for the right subtree, and we'll call for the right subtree first because this is post order. So now you can see that we have the node as 3. So since the node is 3, so you can see that now the node is 3, and we will call on the right. So you can see here that the node was 1. Now we now in the in order array we had 1. Now we will call for 6, 3, 7, and the root for them is 3. So basically the root node will be made as 3 here when we have called on the right. So the root node will be made as 3, and all the elements that lie on the left of 3, okay, they will be considered as what? With respect to 3, whichever nodes lie on the left, they will be considered as the left child, okay, as the children in the left subtree, and all the nodes that are on the right of 3, they will be in the right subtree. So basically what will happen when you will call for 3, okay, then you'll have the node 6 here. Now 6 will be the only node because when you had started, so you had 6, 3, 7. Now when you are on the left of 3, so you only have the node 6. So it will be attached on the, like, basically first of all you will call on the right with respect to 3 because post order is root, then right, then left. So you have got the next node as what? 7. So you have got the node as 7, and basically it is the only individual node present here because 7 is the only segment right now. So what will happen is 7 will be made as the node here, and then you will return this node, and whatever node will be returned, it will be attached on the right of 3. Okay, then after this the index will move on to the guy 6, and when you move to the guy 6, so with respect to 3 you are calling on the left of 3 there is only node one node, that is 6. So since the low and high are equal, so only one node is there. So that is why what I need to do is I need to make this particular node 6, and whatever node I'm making, I will attach it on the left of 3. So I'll attach this node. Now once this particular right subtree is built, then I will return it because my root is done. Okay, then I have traversed my right, I have also traversed my left. So now this part is done. So when I'll return this node, so it will be attached on the right of 1 because I had called for the right call first. Because post order is what? Post order is root, like in the reverse order it is root, right, and left. So I'm traversing the post order array from the right side to the left. Okay, then after this what will happen? Next time when we come back, so now we have the segment 4825, and now the next node is what? The next node is basically 2. So now the next node we have got is 2. So now 2 will behave as the mid. So you can say that here the node will be 2, and all the elements that are lying on the left of 2, they will be in the left subtree, and all the elements that are lying on the right of 2, they will be in the right subtree. So what will happen here is now when you will call, so next node will be 5, and you will first of all call on the right subtree. So next node is 5. So you will say that you will make the node 5 as your right node, and then after this what will happen is with respect to 5 you will call on the right. So with respect to 5, what is there on the right? Is there anything on the right? No, there is nothing on the right of 1. So you'll say that this with respect to the right of 1 there is nothing, so you'll attach null here. Then with respect to 5, is there anything on the left of 5? No, there is no node on the left of 5. So since there is no node on the left of 5, so you can say that it will be null basically. And then this node is made, so you'll return this, and with respect to 2 on the right, 5 will be attached. Then after that you can see that the next node is what? The next node is 4. So you can see that the right call is over. Now you have called for the left segment. So the left segment is basically 4 and 8. Okay, now the next node is 4. So you will see that now you will make the node 4 as the current node. Okay, and then after this you will call on the left and the right of 4. So with respect to 4, what is there on the right? On the right you have got the node, only one node, that is 8, and this node is 8. So you'll make 8 as the node on the right side of 4, and you will attach it. And then with respect to 8, when you will call on the left and right, there is nothing, so basically it will be null. And then you will attach with respect to 4, the right will be 8. Now you can see that with respect to 4 there is nothing on the left side, so that is why this will basically be remaining null. And you can see that with respect to the node 4, it has been made, its right is also done, its left is also done. So you'll return this node, and when you will return it, so it will get attached to basically the node 2. And then you can see that the complete subtree 2 is also made. So now you will return it, and it will get attached to the left of 1, and with respect to 1 on the left, this will be attached. So you can see that we will have the tree as 1, 2, 3, then after that 4, 5, 6, 7, and then 8. Let's check this. So you can see here that we have the tree as 1, 2, then 3, then 4, 5, 6, 7, and then on the right of 4 you have 8. So this is how we have built this particular tree. I hope that you are clear with the logic. Basically the idea is, again I am telling you, that if you have a post order array, okay, so currently if you are at a particular index in the post order array, if you are at a particular element, let's say, So you will do what? You will try to find the position of that particular element in the in-order array. Suppose that element is present here in the in-order array. Okay. So in that case, you will say that this is the midpoint. Okay. If this index guy is present here, then you'll say that this is the midpoint and you need to know its location, that where it is present. So you can use a hash map, and initially you can store the in degree position of every node in the in degree array by using a map. And now once you know that it is at the mid position, so all the nodes that are there from the low till mid minus 1, they will lie in the left subtree when I'll call for the left subtree, and then all the nodes that are on the right of mid, that is from mid plus 1 till high, you can say, they will lie in the right subtree. And since post order is what? Post order is basically left, then right, and then the root. So first of all, you are processing the root, so it's your responsibility to call on the right and then on the left. Okay, because you are iterating from the right side in the post order array. So first of all, the root will be made, then the right subtree, and then the left subtree. Okay, so that is why you'll first of all try to make the right subtree and then the left subtree every time. So let's try and implement this code as well. So what I need to do here is, first of all, I need to declare a map here. Okay, and what I'll be doing with that this map. So basically, let's do one thing. Let's declare one index variable as well. So index variable will always be indicating at the index of the post order array. So I can say that initially the index will be what? Initially the index will be nothing but n minus 1. Okay. Now once this part is done here, so what will I do? So basically I can say that I need to declare a map here. So let's say I'll declare unordered map. Okay. Let's say in this map we'll have the node. Okay. With respect to the node, what do I want? Like with respect to every node, I want to let's say with respect to the node data, because every node can be unique here. So let me do one thing. Let's declare a global map here, and what I will do is I'll declare this map for integer comma integer. So with respect to that node data, I'll store its index. Okay, so let's name this as MP. So what I will do here is I'll iterate in the in order array. So we can say that int I starts from 0, I is lesser than n, I plus plus. Then after this, what I will do is I'll say that map of in order of I. So basically in of I, basically whatever node is there in the in order array, I'll update it with its index in the in order array. Right now, once this is done, so what I will do is I'll say that now whatever now we will be returning what like we'll be calling the recursive function. Okay, and in this recursive function, what we will be doing, we'll be passing several things here. So we'll first of all pass the post order array, and our range is from 0 to n minus 1. Okay, so using the elements from the 0th index till the n minus 1th index, I want to build a tree, and I want to use the post order array, and it will basically return me the head of the actual tree. Okay, so now let's build this as well. So we'll say that we'll have a node star, let's say recursive function. Okay, and we'll have the int post order here. Then after that we'll have the int the low index and in the high index. Okay, low and high are indicating the current leftmost range and the rightmost range. Okay, now what might happen is sometimes that my low might be crossing the high. So basically this is the case when there does not exist any node in the range. So if there does not exist any range node in the range, then I'll directly return null. That is my responsibility. Otherwise there can be another scenario that suppose like otherwise what I will do is I'll make the current root node. So I'll say that the current root node will be what? It will be new node. Okay, and then I'll use what? Post order at this index. So I'll use the post order array, and I'll get whatever element is there at this index. Right, once I get that, so I'll decrease my index as well, because I have to move on the left side of the post order array. Okay, now I will check if my low is equal to the high. So if my low and high are same, in that case what do I need? If my low and high are same, guys, so in that particular case I'll directly return this particular root node, because if the low and high are same, so this means that there is only one node, so I need to directly return it. Otherwise, if there are multiple nodes on the left side and the right side, so I'll say that first of all I'll call on the right and then on the left, as I've discussed. So what I'll do is first of all I'll call on the right, but before that I'll get the index like I'll get the index of this particular element that I have in the post array. Okay, so let's say we have this value only. So let's take this in for terms of value. So let's say the value of this particular node was what? Post order index. Okay, so let's put it as value. Yeah, so basically the node was having this value. Now I will check inside the in order that at which index this particular node is present, and whichever index this particular node is present, that will be my mid index. And how will I build my right subtree? So for this I'll call the recursive function. I'll pass the post order array, you can see here, and then I will, first of all, I have to build the right. So the right will be from where to where? From mid plus 1, that is wherever at this mid index, wherever this value is present, I have to build the right. So I'll build it from mid plus 1 index till the high. Okay. And how will I build my left? So whatever will be built on the left, I need to attach it with the left. So I'll call recursion root dot left will be, basically I'll call the recursion for the post order, and it will be built from low till mid minus 1 here. Okay. Now once this is made, then after this what I will do, I'll directly return the root node here. Okay. So this is how I will build my tree based on the pre-order and in post order and in order. Also, one more thing that you need to notice is how the map is helping me, because otherwise if I had to get the index of this particular element from the in-order array, I would have to traverse, and for every traversal I will take order of n time in the worst case. So that would have been n square, but map will help me to fetch it in constant time. So let's try and compile this and check if it is working fine on the samples or not. Ideally it should work fine. It is working fine. Let's try and submit this code to check if it is getting accepted or not. It should get accepted here. So you can clearly see that my code was able to pass all the test cases. Now talking about the time and the space complexity. So what will be my time complexity? My time complexity is going to be nothing but order of n, because in the worst case I'm iterating through all the n nodes. And space complexity will be how much? It will be order of n, because I'm using recursive stack space as well as map to store, as well as I'm using the map data structure to store the index, to store the in order index of every element. So I hope that you have understood this problem clearly. In case if you have any doubts, you can mention them in the comments. And thank you for watching this video. Keep coding, guys.